Today we're going to look at Intro to Trigonometry. Our objectives are to be able to find the ratios for sine, cosine, tangent, cosecant, secant, and cotangent, and to be able to solve word problems dealing with angles of elevation and angles of depression. So what are our 6 trig ratios? And again, a ratio is just our fraction here, right? A value to a value. And you've probably heard of sine, cosine, and tangent from your geometry class. And if you remember, they deal with a right triangle. The only time these come up, sine, cosine, and tangent, in the methods that we're going to be using today, can only be used for a right triangle. And because in a right triangle, if I call one of my acute angles theta, and theta is our Greek symbol that we use for angle measures, I can now label the 3 sides with opposite, because this is a side opposite the theta. Across from our 90 degrees is always our hypotenuse, and therefore our last side is the side we call adjacent. So if I want to find the sine of my theta, my angle measure, I get a ratio of the opposite side over the hypotenuse, so it just gives me a fraction value. If I want to find the cosine of that angle, it's the adjacent side over the hypotenuse. Again, adjacent over the hypotenuse. So what I would need to know is the 3 side measures. And again, what if they only give me 2? Well, then I can use Pythagorean theorem to find the third one. Tangent is the ratio of the opposite side over the adjacent. Now our other 3 trig ratios you might not have seen before, but what they are, the reciprocals. Remember, reciprocals when we flip our fraction, numerator becomes the denominator, denominator becomes the numerator of our 3 originals. CSC, or cosecant, goes with the sine. SEC is secant, and it goes with cosine, and COT is cotangent, and it goes with tangent. So if you can remember the 3 ratios we have to start with, our sine, cosine, and tangent, cosecant, secant, and cotangent are just reciprocals. It's probably pretty easy to realize that tangent and cotangent go together because they sound alike, but most students mix these up, and I try to remember that sine begins with S, but it goes with the C word, cosecant. Cosine begins with a C, but it goes with the S, secant. Here I have an example of the right triangle, and I just chose one of the families of 5, 12, 13. And I'm asking you for all 6 of the ratios. But if you notice, sometimes I ask for the angle A, sometimes I ask in terms of angle B, and that makes a huge difference when writing your ratio. So I'm just going to deal with the angle A first. So I'm going to put theta up here. And because I'm going to do that, now I'm going to label my sides. Across from the right angle is always the hypotenuse, so I'm going to call it H. If I draw a line kind of through my angle, it's going to point to the opposite side. I'm going to call that O. And then the last side would be A, the adjacent side. So if I ask for the sine of angle A, I know sine is the ratio of opposite over hypotenuse, so that's going to be 12 over 13. If I come down again, I'm just going to deal with the ones I have A. Tangent of A, tangent is opposite over adjacent, so 12 over 5. Now remember, I'm not solving anything, I'm just filling in what the ratio would equal. The last one I'm going to go to secant. Now remember, secant is the reciprocal of whatever cosine is. So if I know cosine is adjacent over hypotenuse 5 over 13, that means secant is going to be 13 over 5. And that's probably the easiest way to think about it. So now I'm going to deal with angle B. So what I want to do is I'm actually going to move this here. Now if theta is right down here, this is still the hypotenuse, but now what happens is 5 becomes the opposite side and 12 becomes the adjacent side. And that's the only thing that changes when you change what acute angle you're at, is which one is the opposite, which one's the adjacent. So now let's look at cosine. Cosine, again, is adjacent over hypotenuse, so this is 12 over 13. And if you notice, when I take the sine of angle A and the cosine of angle B, it ends up being the same values because of that switch. So now let's look at the cosecant of B. Remember, that's the reciprocal of sine. So if I find the sine of angle B, which is opposite over hypotenuse, 5 over 13, that means this is going to be 13 over 5. Okay. Now again, if this said cosecant of A and secant of A, these would be different answers. But because I'm doing the other angle, and I'm choosing the other trig function, not sine or cosine, we end up getting a lot of the same answers. Now what happens if I take the cotangent of B? Well, cotangent is just the reciprocal of whatever tangent would be. So if I'm at angle B, tangent is opposite over adjacent. So if I take the reciprocal, I'm going to get adjacent over opposite. Okay. So does this mean all the answers are the same? No, it just depends on what angle you're at. Okay, it can make all the difference in the world. So hopefully you remember this a little bit. Most teachers use this. So what saying do we use to help us remember the trig ratios? And we call it SOHCAHTOA. And the reason we use SOHCAHTOA is because the letters help us know what the ratio is. So, SOH stands for the sine of our angle is equal to opposite over hypotenuse. The CA part is cosine is equal to adjacent over hypotenuse, and TOA is the tangent equals opposite over adjacent. This is all you need to remember, because if you remember these three, you don't have to worry about remembering cosecant, secant, and cotangent, because all you have to know is it's the reciprocal and which one it matches up with. You don't have to remember 6 new ratios in this form. So what if I give you a problem like this? Theta is in quadrant 2. So what is that telling me? Quadrant 2, if I look at my coordinate plane, remember this is 1, 2, and then I'll just finish it out. This would be 3, and this would be 4. So I know my angle is in quadrant 2. Okay. I want you to find tangent, cosine, and secant of that angle. So remember, what have we been dealing with? The only way this happens is if I have a right triangle. So that must mean I have a right triangle in my second quadrant. And to do that, we always go from the origin, draw our hypotenuse, and then draw it straight down. And when we get to the unit circle, you'll understand this concept a little bit more. And theta always goes right here at the origin. Okay, the angle formed at the origin. And we'll talk a little bit more later about how we can label all of this, but we're just going to put theta right there. And now I'm going to label the sides. They told me cosecant is 7 over 6. So what I usually do is I think, okay, which one does cosecant match up with, or what's its reciprocal? Cosecant, because it begins with a C, helps me remember it matches up with sine. So this tells me that the sine of theta is actually the reciprocal of this, or 6 over 7. Well, I know sine is opposite over hypotenuse, so that means the opposite side is 6, the hypotenuse is 7. So now I can solve for my third side by using Pythagorean theorem, which is leg squared plus leg squared, which I don't know, I'm going to call it x, equals hypotenuse squared. So I get 36 plus x squared equals 49. X squared is equal to 13. So x equals the square root of 13. Now normally we would write plus or minus, but because I'm just dealing in this quadrant, I actually know that I don't need the positive and the negative. Because this is in quadrant 2, I know my x is negative, so this must be actually the negative 13. This is a time where we actually disregard the positive answer, and we only keep the negative. And that's the clue with being in quadrant 2. So now that I know my triangle, I can do just what I did in the last problem. Tangent of my theta, again, tangent is the opposite, which is 6, over the adjacent, which is negative root 13. But we don't like to keep answers like this. And if you remember from our previous chapters, we don't like to keep a radical in the denominator. So I'm going to multiply top and bottom by root 13. So I'm going to get 6 root 13 over 13. And this still stays negative. I don't have to worry about that. I'm not multiplying by another negative root 13. So that would be my tangent ratio. But I also wanted to know what is the cosine of theta. And cosine is the adjacent over the hypotenuse. Now my radical is in the numerator and it can't be reduced, so I don't have to worry about that. That would be my answer for cosine. And the last one wants to know what secant is. Now secant is the reciprocal of cosine. So if I just take the reciprocal and flip this, I get negative 7 over root 13. Again, I don't like to keep the root 13 in the denominator, so I'm going to multiply top and bottom by root 13, and it gives me a final answer of negative 7 root 13 all over 13. And that would be the final answer that I would like to see. And that's how you come up with the 3 ratios that I asked for. And the clue is being able to draw your right triangle in the right quadrant and understanding if you have to solve for that third side, if it's positive or negative. Okay? Now, your hypotenuse is always going to be positive, but your x and your y could be positive or negative depending on what quadrant you're in. So let's try one more. Now I'm telling you that you are in quadrant 4, which is down here. So I'm going to draw my triangle. I know I'm going to go from here. Here's my hypotenuse. And I'm going to go straight down and then here would be my angle. So tangent is opposite over adjacent. So now I got to know, because when you have a negative fraction, you don't know if it's the numerator or denominator that's negative. But in this case, I know my x has to be positive, my y has to be negative. So this is the opposite. So the opposite is actually the -3, and the adjacent is actually the +5. Now, most students make a mistake here, and they see a right triangle, and they see 3 and 5, so they think the last side must be 4. Well, remember, the hypotenuse has to be the longest side, so it has to be actually greater than 5. So I'm going to do legs squared plus legs squared equals hypotenuse squared. I'm just going to call it c squared, just to remind me it's a hypotenuse. So 25 plus, remember, anything squared is positive, equals c squared. And I get 34 equals c squared, and c is equal to the square root of 34. And again, normally when we take the square root, you do plus or minus, but I know the hypotenuse is always going to be positive. Oh, I don't know why I wrote 13 there. 34. The last problem. So, square root of 34, so that means my hypotenuse is positive root 34. Okay, I would break this down if possible, but 34 is 2 times 17, both prime numbers, so I don't have any pairs to take out. So now that I have my triangle, I can now figure out my missing parts. So if I want sine of theta, sine is the opposite side, which is -3, divided by the hypotenuse, which is the square root of 34. And again, we don't like to keep a radical in the denominator, so multiply top and bottom by root 34, and I get a final answer of -3 root 34 all over 34. Now if I could reduce these, I would, but I can't, so that would be my final answer. The next part asks for cosecant of theta. Now cosecant is actually the reciprocal of sine, and what a lot of students do when they see this is they try to do the reciprocal of this, which is really nasty and you have to do a lot of work. Remember, think about originally what sine was. Sine was -3 over root 34, so if I take the reciprocal of that, I get root 34 over 3, and the whole thing is negative. Usually we put the negative out front or near the top. And because I can't reduce that, and I don't have a radical in the denominator, that would be my final answer. And the last part that I'm looking for is cotangent of theta. Now, cotangent is the reciprocal of tangent. Tangent is opposite over adjacent, which means cotangent is adjacent over opposite. So I get -5/3. And that's how you do a problem where they give you one of the ratios and they ask you to find the missing ones. So we're going to get to our last part where we're going to be dealing with actually using trig to help us solve word problems. Okay, so you're given some sort of situation, and a lot of times they deal with these things called angles of elevation and depression, and students make mistakes with these all the time. The main thing that they forget is everything starts with a horizontal line. So I've drawn a horizontal line here. If I want to talk about angle of elevation, that means we started at a horizontal line. Now this could be the ground, it could be an imaginary line in the sky, but whatever we do is we're going to go from here and we're going to rotate up, and that is an angle of elevation. So this is my angle, or theta, of elevation. Okay, elevation because we're going up. Okay, so picture this being a line and being like a drawbridge and going up. Angle of depression does the exact opposite. We start with this horizontal, but instead of rotating up, it's going to rotate down. So if I take this and I rotate it down, so again, think of this, if this is a bridge going up, this would be a bridge going down. This would be my angle of depression. So when you hear or see where it says angle of elevation or depression in a word problem, make sure you have this horizontal line drawn. If you don't see it, draw it in yourself. So let's go through one example, and I'm going to show you an example of elevation and depression problems within the same problem. So a man is standing on the roof of an 80-foot building. The angle of elevation from his feet to the top of a nearby building is 40 degrees, and the angle of depression to the bottom of the same building is 15 degrees. How tall is the other building if the buildings are 100 feet apart? So that's a lot of information, but I always find drawing a picture is best. So we have one building, and a guy is standing on top. So there's our little guy. And he's looking at another building, but because he has angle of elevation and depression, I know the other building must be larger. So I'm going to draw another building a little bit higher. Okay, and let's draw the ground. And we're going to assume they're perpendicular, nicely nicely constructed. So I know from his feet, so we'll pretend like his feet are right here, that if I take the angle of elevation up to the top, I get 40 degrees. But remember, angle of elevation has to come from some horizontal line. And there isn't a horizontal line here because he's not on the ground. So what I'm going to do is I'm going to draw in the horizontal. So that means that this angle here is 40 degrees, which means it'd be perpendicular if I draw that line straight across. So now here's a right angle. I also know the angle of depression from his feet to the bottom of the building is 15 degrees. Now, because I drew in this green line, I actually have my horizontal, so from here down is 15 degrees. Okay. And for degrees, you should always put the little degree symbol to let you know what unit you're in. So what other information do I know? I know that the building he's standing on is 80 feet, and I know the distance between the two buildings is 100 feet. All right, so how is that going to help me? Well, if this is 80 feet, I also know, and I drew a horizontal line here, that this part right here is also 80 feet. And the reason that's helpful is because now I have a couple of pieces of information in this triangle right here. I'm going to call this triangle 1. I'm going to draw this off to the side. I use the same colors to kind of make it helpful. So here's my triangle 1. Okay. And what I know about it is I know that I have this 15-degree angle of depression. I know that the distance between the buildings is 100, so that means this green line is 100 feet. And because the smaller building is 80 feet, I know that this is 80 feet. So, okay, and what I want to know is how tall is the entire building? Okay, so how is that going to be important? So, if I want to know how tall the other building is, I need to know how much this little piece is, because then I can take 80 and add it to this top part. So I actually don't have to do too much work in this triangle, but I do need to know the other triangle. So let me draw that one out. I know that I have this red line, I have this green line, and I know that this is a right angle, and I know I have an angle of 40 degrees. Okay, but I only actually know one piece of information in this triangle, that this is 100 feet. But I'd really like to know how long this side is, because if I know how long this is, I can add it to 80 to figure out the height of this entire building, because I know this one's 80. So how could I do that? Well, now I have a right triangle, so I'm going to set up my SOHCAHTOA. So I'm going to label this side as the opposite side, this side is the adjacent side, and this side is the hypotenuse. So I'd really like to know the opposite side, but they did tell me the adjacent side, and I do know an angle measure. So let's think about that. If we write out SOHCAHTOA, and I suggest writing that out each time to help you out. So SOHCAHTOA. Alright, if I look here, I want to know the opposite side and I know the adjacent side. O and A come from the ratio of tangent. So if I write tangent, and we usually have theta here, but what is my angle? It's 40 degrees equals, and the ratio for tangent is opposite, which I don't know, over adjacent, which is 100. So how would we actually solve this for x? Well, we did a whole bunch of problems where we had a fraction equal to a fraction, we cross-multiplied. So x times 1 is x, but 100 times tangent 40. The big mistake that students make is they do 100 times 40 and think it's tangent of 4,000, okay, which is not possible. You're not multiplying 100 times 40, you're multiplying 100 by this entire thing, and this is linked together. So it's 100 times the tangent of 40. We always like to put our numbers in front, kind of like if we had 2x, we write 2 and then the x, not x and then the 2. So how would I type this in my calculator? Well, I'm going to pull up a calculator here. Okay. The first thing you want to do when doing any trig problems is to check the mode of your calculator. And if you look right next to your second key is the word mode. If I hit that, I'm going to look 3 down, and most of them are the third one down. It says radian and degree. Now, we'll be talking about radians in our next section, but we are dealing with 40 degrees, so I want to make sure my calculator is in degree mode. This won't affect any other functions that you do with the calculator, so you don't have to switch it back and forth. It only affects when you're dealing with these three buttons, sine, cosine, and tangent. So I'm going to quit out of this, and now I'm going to type in exactly what I see. 100 times tan, or tangent, of 40, because we need to tell the calculator that's a 40 degree. I'm going to hit enter, and it gives me an answer, 83.9. Okay, so let's say we round this, so the other building's approximately 83.9 feet tall. So it's not much bigger. It's only 3.9 feet bigger than the original one. And again, your pictures don't have to be drawn to scale, but you want to draw a picture to help you out. And this is how we were able to draw this out to let us know. But remember, what I just found is not actually my final answer. So, what is this? Is that how high the building is? No, all I found was this little part here. And after doing all this work, usually what happens is we get an answer and we stop and we circle this and we think we're done. But remember, what did we solve for? We solved for x, which is this little part here. But I wanted to know how tall is the whole building, not just the missing part. So I have to take the 83.9 and add the 80 feet that we already know is below it. So my final answer should be 163.9 feet, which is significantly taller than the other building, over twice as big. And that is your final answer. I hope you feel a little bit better about dealing with ratios of sine, cosine, tangent, cosecant, secant, and cotangent, and being able to deal with a problem that has angles of elevation and angles of depression.